Good morning, everyone. I'm Liz Pearce, an Assistant Director within the Chief Technology Office within the Australian Space Agency. Thank you all for joining today. I would like to acknowledge the traditional custodians of the land on which we meet today. For those of us in Adelaide, in South Australia, we're currently on the lands of the Kaurna people, and I pay our respects to their elders, past, present, and emerging. And I extend that respect to the Aboriginal and Torres Strait Islanders on the call today. Welcome to today's information session on the Robotics and Automation Roadmap, which was published earlier this year. Today, I am also joined by Nick Larkham from the agency's Chief Technology Office and guest panelists Jonathan Ralston and Ross Dungavel from CSIRO. Here is a quick overview of the content we'll be presenting today. Just to note, the session today will be recorded and distributed on the agency's various digital platforms. After this session, we'll have a Q&A, and you can join the conversation by adding your questions to the Q&A in Teams. As I mentioned earlier, there's a button at the top of your screen. Today's webinar will run for approximately 45 minutes. And at the end of our session today, we'll have an industry pitch in which we will hear from 10 organisations within the RNA sector. So I encourage you to stay all the way to the end. So here are the details you'll need to be part of the conversation using Teams Q&A. The button should be at the top and submit anything you like during the call and at the end. So I'd like to move into the process on how we develop these roadmaps. In 2019, the agency released the National Civil Space Strategy, and within that strategy, we highlighted 7 areas of priority where Australia has opportunities to grow a national space capability. The purpose of our roadmaps is aligned with that strategy, to foster an aligned, connected and informed Australian space sector that is united behind a shared vision for each priority area and provides clear pathways to meeting our ambitions. The roadmaps are and will continue to be the agency's strategy for implementation of our activities, programs and missions. We are focused on areas where we can build a sustainable activity based on competitive advantage. To achieve this, we came up with a list of criteria for a capability to be included in the roadmap. To be included, a capability must strive towards bold visions and ambitions that align with the strategy, have the potential to synergize with other selected capabilities to uplift the sector in an enduring manner, and be based on a comparative or competitive advantage and/or be an area of national strategic interest or be a necessary input to realize another included capability, even if the input itself isn't a competitive advantage. We recognize, of course, that over a whole decade, new needs, opportunities, and technologies will arise, requiring these roadmaps to be constantly reviewed against these criteria, but the criteria will remain constant over that time. On the next slide is a diagram called the Roadmaps Nexus, and that shows how all our roadmaps are connected. The roadmaps are reliant on cross-cutting technology areas that critically underpin our competitive advantage. They are facilitated by non-technical enabling capabilities, which you can see at the bottom, we call facilitators, which are the ecosystem builders and are what enables progress towards reaching our targeted capabilities. These capabilities may be applied to cross-cutting services, which you can see on the right there, where we think there is the greatest opportunity for our space sector to apply these technologies and capabilities moving forward. On the next slide is the chronological development approach to each of our roadmaps. The approach to build up the roadmaps is something we developed to ensure a consistent, evidence-based approach to our technical strategy. Phase 1 is assessing the opportunity today. Where are we in the global context? We look at the markets and needs within Australia. Phase 2 is about the targets and looking to the tomorrow, the decadal timeframe. Where should Australia be? What does Australia need? And what can Australia do in a sensible way? Phase 3 is about planning the path between the two. Phase 4, we then go forward and implement that plan, including future updates. This was developed in consultation across the entire sector. We receive feedback and support to the validation of the assessments of Australia's state-of-the-art capabilities, technologies and opportunities by peer space agencies and stakeholder organisations. We are so grateful to all of you here today who have supported the development of this roadmap, and we're proud to share it with you today. I'll now pass over to Nick Larkham, who led the development of this roadmap, to give you the details behind the document.
Great, thanks Liz. G'day everyone, my name is Nick Larkham and I'm with the CTO office at the Australian Space Agency, and welcome. We really appreciate you taking the time out of your busy days to hear about what we've been working on with the industry and what the future looks like. And today's going to be discussing about what the future looks like, the direction we're going, the capabilities we need, why we want to go there, what we think it could do, and I'm going to admit I'm pretty darn excited about this one. So there are opportunities off Earth and they're on the rise. So what do we mean by this? Well, space is changing. Space is changing in a good way. There is more opportunities for more people doing new things, tackling new challenges, going where we've gone before, but hopefully a little bit further, and there to stay. But what are we going to do? What is Australia going to do in this area? Because we are new. We are new to the space game, at least in the 2.0 context. So we've got some opportunities. We've got some things we could learn. But how are we going to go about this? So as Liz said, we worked to develop a state-of-the-art, to know where we are, develop targets, to know where we want to go, and a pathway to know how to get there. But these rely on our competitive advantage. They come out of our resource sector, our robotics sector, our agriculture sector. And we think we have these capabilities. We think we have the tools. We think we have the experience, that we do have a lot to learn, that we can start tackling some of these big, scary, but exciting challenges. This is the direction we're going. We're going to go out and tackle the big challenges, because that's where we can have our impact. And it's going to be a bit of a hassle to get there. There's going to be some missteps, but we are confident that if we work together as an industry, as a sector, as a nation, there is a real opportunity to do something great. So what are we going to do? So if we move on to the next slide. Foundation services. This might be a new term to some, or not so new. But when we first started out on this roadmap, we kind of knew we were good at some things. Resource sector, kind of good at the robotics. We're good at making things fit together. You know, we can control things at a distance. But how do we fit that together? How do we fit Australia's potential capabilities, our capacity? How do we fit this together and present this in a way that is digestible and wanted for the future? So we've come up with what we're going to term foundation services. Now, I'm going to read this one out to you because the wording here is quite important. Foundation services. They are operational services that support exploration missions to build towards and eventually maintain a sustained off-Earth presence. They are services which the demand is recurrent, continuous, or enduring. The scope of foundation services covers monitoring and inspection, planning and logistics, civil construction, materials transport, cargo handling, remote maintenance and salvage, component manufacture and assembly. And importantly, foundation services are distinctive but complementary to mission critical systems such as power, communications and life support. Now I just want to break this down to you because this kind of shows our thinking, and when it comes to making decisions for the future, there's a little bit of crystal ball gazing, but there are some things that are important and that you can make decisions on to ensure we go forward. So demand is recurrent, continuous, or enduring. We don't want one-offs. We want Australia to be needed from day 1, day 20, year 1, year 20, year 100. We want these to be continuous. You know, it's not just once a year, it's operations that are constantly in need and enduring. And while the scope can seem quite large, we believe all of these capabilities are interconnected and rely on our competitive advantages to deliver these opportunities. And importantly, we're distinctive but complementary to current mission critical systems such as power, communications, and life support. So this is what we have to offer. But how did we get here? And what direction are we going? In the next slide, we'll talk about the vision and our ambition about what we would like to see as the nation in this segment. So I believe in having a very big vision is really important, but also we have the ability to take the smallest step in that direction. And then before we know it, the future will be here. So I'm going to read out the vision to you. Australia will build, operate and maintain off-world infrastructure and assets to expand, support and sustain humanity on Earth and in space, and in a manner that supports the long-term sustainability of outer space. We're going to do this. I don't know about you, but building and operating infrastructure and assets off-world it's exciting. And support and sustain humanity on Earth and in space, because we're not just going for space. We believe these benefits will absolutely come back into support activities here on Earth, and we're going to be doing this in a sustainable manner, in a continuous manner. So that's the direction we want to go, outwards and upwards. But our ambition, who do we want to be? We want Australia to be the leading and trusted, responsible provider of these foundation services, providing critical solutions into the global marketplace that enable and support the sustained build-up of space assets and infrastructure. I think you might be getting a bit of a theme here. We want to be sustained. We want to support the build-up. We want to provide these services into a global marketplace. We really think that Australia has an opportunity to supply and deliver useful, exciting services for the future. And we've just got an artist's rendition of what a potential future moon base could look like with our support services facility in the front. If we move on to the next bit, I'll talk about the focus segments. So that's the direction we're going. That's kind of what we want to offer, but how did we get there? So we developed these 6 focus segments. These are areas of opportunity, or areas that we need to realize the areas of opportunity. We have our remote operations, analogs, facilities and services, in situ resource utilization, interoperability, robotic platforms, and foundation services. We believe tying all of these areas together can help deliver this vision. If we move over to remote operations, it's the ability to manage and monitor, control an activity where the operator is separate from the activity site. That sounds like space. That also sounds like a lot of the activity we do here on Earth already. These are scalable operations of multi-asset systems and often facilitate robotic and appropriate levels of automation. And they've got to work together. They've got to work together between everybody. So we think we've got some pretty good experience here. We're really good at controlling mixed multiple assets over a long distance in a safe and productive manner. And we think we can do it on the moon. There's going to be some steps. There's absolutely some learning to do, but we think we have a competitive advantage that we can take forward. And we really want to have the ability to be the ones in control, because being in control means you're the ones who are responsible. You're the ones who are lead and make those decisions. And you're the ones who can ensure this is a sustained build-up of operations off Earth. I'm going to pass over to Jonathan Ralston now from CSIRO. Jonathan was one of our key members in supporting the development of this roadmap. He's going to talk through a few of the focus segments. Jonathan.
Great, thank you, Nick, and hello everybody. It's great to be here. I'm just going to touch on 3 of the focus segments, and I find them actually as exciting as Nick does as well. But just before I do, I also wanted to just acknowledge my SIRO colleagues, Chad Hargrave and Ross Dunn-Gable, who are also very heavily involved in this roadmap development process. But firstly, interoperability. Interoperability is really this fundamental ability to how we interconnect and integrate systems. I really like this as a theme because it involves both creativity and clarity. It's very broad. It spans mechanical and electrical and thermal and communications, power, all sorts of different services. And it's essential for any successful operation here on Earth, but certainly in terrestrial context as well. So the ambition really here is to see how Australia can leverage its existing capabilities across its extant domains to really rapidly develop an interoperability capability. It's very important, great benefits also for people who are trying to enter into this realm, particularly providing confidence that any subcomponents that get developed, people will be able to rapidly enter into and connect these systems well. I think also for customers, it would allow them to sort of mix and match components from different people providing and supplying components, which is a very good component element as well. What are the sort of things we're talking about with interoperability? Things like system and process architectures. These are things like reference designs at that systems level detail, open system interfaces to allow protocols to intercommunicate and subsystems to function well. Also touches on things like validation and verification and testing and evaluation. So it's an incredibly important component that will now enable different systems from right down to the subcomponents to entire missions to interact well. And I think Australia has an amazing opportunity here to really lead the way, particularly for planetary systems interoperability. On to the next segment now, analogues. Analogues are really provide environments and conditions that are very similar to the target environment, and it's essential for us learning, for technology development, validation and testing. It's also a fantastic way for us to de-risk technology development and look at different environment scopes. The neat thing about analogues is it's actually quite easy to begin in a scaled way. Analogues span right from specific experiments on a test bench to a facility that looks at some particular condition that you might encounter on the Moon or Mars. Then it also spans into things like analogue sites, which Australia has many natural locations that have similarities both geologically and morphologically with our mission destinations, and it's a fantastic opportunity for us to leverage that natural capability that we already have. And then finally, analogues can even span things like the entire mission simulation. So looking at how we might represent an actual system in an analogous environmental condition. So Australia does have this opportunity to offer the world terrestrial analogue testbed facilities to actually facilitate ongoing systems validation and testing. Big opportunities for Australia. You know, we could do things such as having integrating our existing capabilities, like a national terrestrial catalogues, facility developments to characterising test beds, vacuum chambers, and so on. There's also an opportunity for virtual analogues, where we could be developing realistic digital emulated environments, where we could, again, touching on the interoperability components, where common software components could be interoperated and used to accelerate our development process. So it's a very accessible area. It's something you can almost start today. It's exciting to see the number of, for example, test beds that are being developed all across Australia, and that's certainly an area that we can actually burgeon and expand and for really provide not just a national benefit, basically also to benefit the international community. Just like to then talk about in situ resource utilisation. ISRU is an area that's near and dear to our hearts here at CSIRO, and it's really about utilising the materials that you find in the destination environment to support a sustained mission activity, whether that's identifying the material just to build things, or whether to process it to provide consumables. It's a very exciting area that's been on the roadmaps with agencies for a couple of decades. It has a great connection with Australia's capability, particularly in the resource sector. It represents a sort of a space resource supply chain and spanning things like identification and collection and processing and use of those resources. And really the aspiration here that's represented in the roadmap is for Australia to be recognised as a major player in providing the component technologies that can support the build-up of sustained operations. And there's tremendous opportunities both for spin in and spin out in this particular area. So what are the major areas of interest in ISRU? Resource prospecting is certainly the first part. Australia is a world leader in terms of its geophysical technologies and so on. There's some wonderful opportunities to develop new sensing instrumentation that's actually going to work in the target environment. Resource extraction technologies for ground engagement, development of materials and technologies to operate in extreme environments, resource handling, and then finally resource processing, which is probably the thing that people go to when they think about in situ resource utilisation, which is this ability to transform the raw resources that you find in the environment to provide really important constituent products to support long-term mission and presence. So I find those segments very exciting, and many opportunities for us to begin, even in very simple ways, this afternoon and certainly into the future as well. So thanks very much. Back to you, Nick.
Great, thanks, Jonathan. So we've spoken about remote operations, the ability to control over a distance. We've spoken about interoperability, to make sure it all works together over a distance and at not so much of a distance. We spoke about our analog facilities, how we're going to be testing these to enable rapid iteration. We've spoken about the in-situ resource utilization, using these tools and knowledge that we have gained to help support the sustained build-up of operations. But if it's not an astronaut, how are we actually going to do these things? How are we going to touch the world? And that's where these robotic platforms come in. When I was first tasked with looking at this area, the comment was we were kind of good at robots kept coming up, but it took a little while to find out exactly what that is. And where we excel is not so much the universities, though there is some great robotics there. It's not so much the manufacturing robotics, though we do have some good capability there. It's the field robotics. It's the taking these poor robots out into the very harsh Australian environment and torturing them excessively and having them still perform. For them to do the dull, dusty, dirty and dangerous work out in the field, that's where we have the advantage. And that's where we're looking to continue to help with these going forward. Now, we could, of course, have an astronaut do a lot of these tasks, and they could be better than a robot in a lot of cases, but do we want them to do it? We could send an astronaut to the lunar surface with a shovel to make a road, but I figure there could be a better use for their time, and that's what we really want to focus on these robotic platforms. So we want to develop autonomous systems that are trusted, robust, and persistent. Trusted, robust, and persistent. You know, we've got to be confident with these robots operating around us, around humans, off Earth, whether or not it's an astronaut or somebody else's equipment. They've got to be persistent. We want them to stick around, and they have to work together. You know, Australia can't be a winner take all. There needs to be multi-vendor, multi-user. And we want to sense, perceive, and collect in-situ data and model awareness. We need to understand these environments. We need to understand these environments that we operate, that we want to operate in, and the wealth of scientific information. It's really exciting coming forward. We're looking to develop and deploy mobility platforms. What does this mean? Robots that move. How do they move? That's up to you. We have legs in the picture here. Could be wheels, could be tracks, could be hopping. But we know we need mobility, and we know we need your understanding to help deploy these systems. And we need this mobility in complex and rugged terrain. All the good science tends to be off the road, over the outcrop, down the lava tube. We need to have the ability to reach beyond, and we need to have the ability to utilize and develop these systems with AI, edge compute, distributed computation, all these non-traditional architectures. There is a real chance to push the limits here, because on Earth, it's always really tempting just to offload that. But space is a challenge, for better or worse. You have to push yourselves. So we can remotely control. We are interoperable. We can test. We have the tools, and we have the robots. So if we move on to the last slide on the focus segments, we're back to foundation services. So hopefully you can see there's a bit of a narrative coming together here. We are looking for services that are continuous and enduring. We really believe this is the first step on a very long path, but with very many opportunities. And while these other bits are absolutely essential, that's where we have this capability. This is what we're looking to do with it. So let's talk a little more specific about what we're doing. Monitor, plan, and coordinate asset utilization. Well, it's all well and good to be able to control something, but what's that other country doing? What's your battery power at? What's your stockpile? Is there a spaceship coming down? The ability to control and plan all of this logistics is incredibly important, and we feel that we have a strong competitive advantage coming from the resource sector. There's lots of mixed and moving parts working together, and we think that this is a real area of opportunity. Resource and material handling logistics. This is moving dirt. And why are we confident that this is going to be continuous and enduring? Because when we first started building objects, we had to move dirt. When we first started building buildings, we had to move dirt. I can look at my office window, and for better or worse, construction is still ongoing. And we're confident that on the lunar surface, we will need to be moving regularly. Whether or not it's Earth moving or Moon moving, we're yet to have that debate. But we need to be moving these assets to help. And again, we can start small. It might just be as simple as clearing all the rocks around a base, because if an astronaut walks out and sprains their ankle, that's really not great, but that's a task that we can do. You know, we've moved all these beginning works, but we can, you know, primary construction, civil works, build those roads, build those buildings. It's going to be a long journey till we have this capability, but these are steps that we can take incrementally. And importantly, these are areas that benefit from more players. They don't suffer. We don't want to say, well, there is a company doing that, it's done, it's not good. It helps to have more bulldozers. It helps to have more building bots. We really want an entire ecosystem to develop here, and we believe it's essential. Okay, so we're doing all this stuff, right? But it might not be as exciting, but it's as important. Remote inspection, maintenance, and salvage. And this is probably some of the first things we're going to be doing. Okay, the wheel doesn't turn. Could be our wheel, could be somebody else's wheel. Why doesn't it turn? Is there a rock? Is it busted? Is it jammed? Maintenance. Everything breaks, for better or worse, eventually. And again, we believe this is a real area of opportunity to combine all of the previous focus segments to help deliver that sustained build up of Earth. We're gonna fix things. We're gonna build things to be fixable. We're gonna be able to support our partners of Earth. And when things eventually do come to an end, salvage those and bring them back and give them a new life. And we're looking to tie that together with component manufacture and assembly. Yeah. We really want to focus on the ability to send the least amount of mass, but be sustainable. We might be making shovels on the moon because TRL-9 shovels, they're out there. But do we really need to be bringing them from Earth? Tying all of these together into what we call foundation services, we really believe we have a unique offering that builds on our competitive advantages, our history, our friends, our partners, to deliver a sustained off-Earth operations. So if we move to the next slide, we've talked about the things that we think we need. We've talked about the vision, the direction, and how they all link together. But how do we get there? What are the steps? So we have come up with pathways on a timeline. We believe, and with the help of our technical advisor groups, industry, academia, and other fellow government agencies, that these are the key steps that we need in each area to develop and deliver these visions. Where possible, these boxes are capabilities opposed to technologies. How they're delivered, that's up to you. You are the best ones who know how to tackle that problem. And just because somebody's working that box doesn't mean you can too, can't too. You can move in and work, you can work with people, and we're seeing that already. We are seeing early boxes underway. We have remote operation centers, we have analogs, we have challenges. We are beginning to do cargo handling studies. These are the ways to move forward, and this is what we refer to. When people ask us what we're doing in this area, we hand them the roadmap and say, this is what we're doing. When you come to us and point to the box on the roadmap and say, this is the box that I'm doing or working towards or want to work on, because that's how it all fits together. and it's probably not clear on the slide, but you see that little white slither down the bottom, foundation services? While these roadmaps are not funded directly, they are the guiding post on how we deliver. That white box is Trailblazer. We are taking a robotic platform to the moon to support NASA. Now, that might have seemed not possible 5 years ago, or even 3 years ago, but today it is. It's underway. Some of you are already working on it. We are working on a robotic platform to deliver foundation services. We believe this is the start. We've had feedback from our partners overseas that this foundation services is a real area of interest. It brings additionality. We can support them, we can enhance their work, and we can be part of what moves forward. So my question to you, which of the challenges laid before you are you willing to tackle? Which bits can you and your team undertake towards delivering this vision, this future? Because we rely on you to deliver this, and we see the future as exciting, bright, with many players, and maybe in the not too distant future, this picture behind me might not just be a picture, might not just be a rendering. So I'd like to say thank you. Thank you for taking the time to join us as we present the Robotics and Automation roadmap by the Australian Space Agency. We were supported by industry, academia, government agencies, partner nations, and other space agencies. We look forward to what comes next. And a bit of a spoiler here, but we have some industry showcase of groups already working on these challenges. And from when we first started working on this a few years ago to now, there is so much more activity that I can't even keep across it. And that's amazing. So with that, I would like to turn it back over to Liz.
So that concludes the formal part of the webinar, and now we're moving into our industry pitch session. We have 10 organisations that have been selected through consultation to present their pitch today. Up first, I would like to introduce Professor Andrew Dempster from University of New South Wales. Andrew.
Thanks. Have you got the slide? Great. Thanks, everybody. Yeah, so UNSW has the largest and highest ranked engineering faculty in Australia, and we have 5 schools in the faculty who are interested in this area. We've been working on space resources for about a decade. We've had 17 PhD students going through. The 2 that are graduating this year are on there on the slide, looking at asteroids, but we are doing a lot of work around the moon on lots of technological stuff, but also across the board on law, ethics, environment, and business case type scenarios. We've recently won 2 grants from the Australian Research Council, the first with Sydney Uni and Macquarie, and the second with QUT for facilities. So these will be analogues that we can use for this work. A moon yard and a dirty thermal vacuum chamber are the key ones in that second one that relate most directly to this. We ran the 5th Off-Earth Mining Forum just last month, and we had contributions there from NASA, ESA, the Japanese and Korean space agencies, and also a Canadian company. So a lot of, and the Luxembourg Space Agency, who are leading this work in Europe. So a lot of exposure there for the work we're doing, and we are, internationally recognised as being very strong researchers in space resources. And just a little shout out to some undergrads. We had a group of undergrads recently enter the Over the Dusty Moon Challenge, where they were funded to go to the US, to Colorado, to compete, and they came 3rd against international competition for a regolith movement problem, where they used a chairlift type arrangement. And while they were there, they attended the facility launch of a company called Orbit Fab, which is an in-space assembly company. CEO and CTO, both Australians, both UNSW graduates. So it was a really good occasion. We've only got a minute, right? So I'll stop.
Thanks, Andrew. Appreciate that. And that's really great news. Thank you for sharing. All right, we're moving on now. I'm going to introduce next Mikhail Asavkin from Ant61. Mikhail, are you ready?
Can you hear me all right?
Yes.
Cool. Hi. Thank you for this opportunity. Okay, so my name is Mikhail. I'm from N61. Oh, yeah, that's my slide. Cool. So at N61, we also share the agency's vision that the future of humanity in space will be sustainable. And we believe that autonomous robots who are hardened in Australian desert will be the key for that. Our main focus is on the brains for such future robots, allowing them to work together and perform these high-level tasks rather than following the joystick commands. So that's exactly what we're doing. So in a few decades, our robots will be providing construction and continuous maintenance services for future lunar and Mars colonies. But since there are no customers on the moon today, we're currently building orbital robots that will replace batteries and upgrade cameras and sensors on geostationary satellites and sun-synchronous satellites. And with this on-orbit servicing, autonomous system is just a way for us to lower the cost of such services, because we would not be relying on remote control, which means a lot of expensive hardware, a lot of power. And this learning will also help us to later apply the same technology where remote control will be not just very expensive, but just impossible due to speed of light limit, which we already mentioned. So our first mission coming in 2023, we're going to put our robotic brain in orbit as a secondary payload mission. And our focus being on control mechanisms, primarily we really looking to partner with hardware providers, obviously satellite manufacturers and everyone else who wants to build something in orbit and then later Moon and Mars, or maybe asteroids. Thank you.
Great. Thank you very much, Mikhail. That sounds all really, really exciting. Okay, next up, I'd like to introduce Dr. Nathan Wallace from the Australian Centre of Robotics at the University of Sydney. Nathan.
Yep. Hello, can everyone hear me?
Yes.
Okay, great. All right. So, hi everyone. I'm Nathan, a postdoc researcher at ACFR, and I'm just going to present to you a brief bit today about the Project Dingo that we've been working on as part of the feasibility stage of the ASA grant. So, the mission concept for the Project Dingo involves a robot performing autonomous sample collection, retrieval, and analysis tasks on the lunar surface, prospecting for materials and resources valuable for supporting the operation of a future lunar colony. Our contribution towards achieving this goal is to develop an intelligent sampling algorithm which plans the rover mission and motion such that it can efficiently gather information about the distribution of these resources of interest in the environment over a region of the lunar surface. So solving this problem poses several challenges, including the need to avoid hazardous terrain, handling fluctuations and downtime in communications, as well as managing several budgetary constraints on the rover's operation, such as limited energy reserves and a sample cache space. So during the feasibility study, we successfully developed a proof of concept for this algorithm and system and demonstrated both strong performance and autonomous operation, both in simulation and in real-world field trials using a physical rover and sample collection system. Thank you.
Thank you, Nathan. Really appreciate that. All right, next up is John Coulton from the University of Adelaide. John, are you ready?
All set. Thanks, Liz. Good morning. I'd just like to talk about the Andy Thomas Center for Space Resources here at the University of Adelaide. The mission of the Andy Thomas Center is to support long-term human presence in deep space. And in support of that, we offer a number of activities and facilities to potential like-minded collaborators from government, academia, and also in partnership with fantastic industry players such as Astroport Space Technologies, for example. I think 4 of those activities are on the slide here that you can see. I think most of you probably know that we host the annual Australian Rover Challenge, and we welcome university teams from across Australia and New Zealand to participate in that each March. We just opened our Extraterrestrial Environment Simulation Lab, which is a civil engineering facility. And within the academic world, the topic of civil engineering really spans quite a number of the activities that Nick mentioned that are part and parcel of foundation services. So in that lab, we will prove out many of those kinds of technologies in 2 regolith thermal vacuum chambers. We have an instrumented regolith pit with 10 tons of Lunar Highlands simulant in it, instrumented sand pit, and then a construction component production line with all the tools you would need to investigate that. We do have an Xterra's mission control that I'm sitting in right now, where we can operate our mixed fleet of robotics across a number of domains and with a number of international partners. And then we're in late stage planning for the installation of a large scale Moon to Mars analog facility at our Roseworthy campus, where we can integrate multiple teams of rovers and astronauts that will be working together across a number of foundational services activities. So thanks very much for the opportunity to chat. We would love to hear from anybody who would like to collaborate and utilize any of these facilities with us. Thanks.
Thank you very much, John. That's all really, really interesting. Okay, next up is Tim Lucas from Raytracer. Tim, are you ready?
Hi, everybody. So a little bit about Raytracer. We're also a recipient of the Australian Space Agency's feasibility grant. So we've been working on robotics, particularly around command and control, and really mixing up the methodology of how robots have traditionally been controlled. We're looking at scalability and how we can put more robots in space and allow fewer people to be required to control them and conduct complex tasks. As part of our study, we've controlled a 7-axis robot arm remotely from QUT University without anybody having actually seen the arm in person. And we've been able to add in properties like latency and link drop and things like that, and show that people can still be productive within our control environment, and done A versus B testing with more traditional control schemes and shown what advantages that has over current systems. And really we're developing a lot of digital twin technology and looking at how we can replicate environment and show changing variables and gamify interfaces so fewer people can really get in and have their intent translated into real mechanized output from multiple machine swarms. And we've actually seen commercial success already and been able to join commercial projects here on Earth from some of the work we've done, and are in discussions with some other potential use cases for space as well. A lot of these are edge cases where people have run into an issue with traditional command and control, where it really isn't able to do that next step without adding a lot of human complexity and overhead and cognitive load. So we're really able to manage the semantics of a situation and present that in a unique way, is our findings to date. And this relates across to drones, rovers, robotic arms and things like that. And really we see the value there all the way through from mining, all the way across to just not needing to leave a habitat to move a piece of luggage. We think robotics will play a very important role, which has been highlighted, I think, unanimously here.
Great, thank you so much.
Thank you.
Thanks, Tim. Okay, next up is Ali Bushberger from QUT. Ali, are you ready?
Hi, everyone. Can you hear me?
Yes.
Great. Lovely to connect with everyone. Thanks, Liz, and thanks, Nick. Nick, we've tortured a lot of robots at QUT. Arguably the largest robotics research centre in Australia, around 100 researchers, staff and PhD students. We've done field robotics and autonomy solutions for the likes of Rheinmetall mining companies and METS companies like Caterpillar, and have begun adapting that with companies like Boeing to a lunar context. We've got a wonderful 12-person team led by David Flannery, who drive the scientific consensus around where Perseverance will go during the US night when NASA JPL is sleeping. David also was a chief investigator on the Pixel instrument, so really good at developing high performance lightweight instruments that can characterise rocks on planetary bodies. We've got the only capability in Australia to manufacture lithium-ion batteries, and a really fantastic engineering team, including a cohort of aerospace engineers that back all of that up. We've also got a group of folk who are very good at robotic manipulation. We've built AI that can win a major chess tournament but can't yet grasp a chess piece. So these guys are really great at that. We've just spent a year with MDA developing a prototype that could be used on ISS and ultimately Gateway to autonomously cargo transport bags. Underpinning all of that, we've started development of a $5 million lunar test bed designed to be highly complementary to CSIRO and others. It's an outdoor facility, very large, 20 metres by 10, has a wonderful spot for digging, has a gravity offset mechanism as well. Can fairly, with a high degree of fidelity, simulate lunar lighting conditions, and obviously has a manufacturing space attached. So a greenfield site bordering, for anyone who knows Brisbane, Victoria Park, which is a site for the Olympics. So the idea that this is a co-location opportunity, it will be the first stage in our space precinct, but with huge outreach potential and public engagement as well. It's not just for QUT, as I said, it's being a university facility, we want to see used by the ecosystem. It's for everybody. We want to see it being used. Our partnerships are really important to us as a university. And, the roadmap really, I think, Nick, you captured it well, identifies a really bold and ambitious agenda, really big missions that require big collaborations. And I think will really be the collective achievement of the Australian government, our research sector and industry working together. So we take that quite seriously. Thanks, Nick.
Great, thanks, Ali. Okay, next up we have Darshan Sridharan from Piston Labs. Darshan, are you ready?
Yes, thanks, Kate. So I think everyone understands there's a lot of risk in the construction sector at the moment, and so that's one thing we wanted to capitalize on. Understanding that our moonshot or our key goal is really to help out with the lunar construction efforts, understanding that we can't send 50 tradies up there to build a building for us. So really getting to this, I guess, getting to the specifics of it about creating an autonomous ability to have robotics or multiple swarm capabilities to effectively build these, whatever it might be on the moon. Understanding we're probably not going to build a skyscraper, but maybe those foundational components that we need to build upon. One thing we understand is we can't just go straight to the moon. So idealistically, what we want to get it working in an agriculture context. So essentially multimodal robotics, whereby it can do more than one task at any one time, then leverage that into an on-Earth construction setting, which becomes more important for the manipulation functionality before then, I guess, putting on the extremities of what the lunar environment would be. So this is something we're still playing around with from an R&D perspective, given there's a lot of different moving components. But I think one of the more satisfying things is every part of what we're trying to do has been created in some way, shape or form. It's about integrating it all and coming back to the interoperability point, getting it all working together for the lunar context. Thank you.
Great. Thank you very much for that, Darshan. Okay, next up is Sam Zimenez from Astroport Space Technologies. Sam, you ready?
Yes, I am. Thank you very much for letting me explain who we are. Astroport Space Technologies is a lunar infrastructure and materials development company. Talk about the ultimate foundational service. We are focusing on lunar landing pad development as our initial infrastructure development. You see in this picture here in the middle there the BrickBot robot that we are using. We actually have funding from NASA to develop a unique way to solidify the regolith, melt it without any binders. It's pure melted technology, and we acquire the regolith, we place it into the hopper, form the shape of the brick, and then we place it onto the surface. So one-step process. We just finished delivering our first prototype to NASA yesterday. On Sunday, and now we're going into phase 2 of this program. We also just received another NASA award together with the Andy-Thomas Center for Space Resources. John Colton and his team up there, we're going to be working together as a team to develop the site preparation, regolith movement applications. How to actually prepare the site and develop it for application of our unique BrickBot application. So we're excited about that opportunity. We will be able to look to do some real geotechnical engineering and to identify how do you actually take the bulk regolith and excavate it, convey it, filter it, sort it, get it to the BrickBot so the BrickBot can do its job of laying down the bricks and the tiles. And we'll be also looking at the foundation, the pavement aspect of it, and the structural design of the actual pad. So we're have a number of collaborations as well. In this picture, you see the hauler there. We have a company that we're collaborating with in Poland. We were recently selected by the European Center for Space Resources, ESRIC in Luxembourg, to one of 5 companies that were selected from 33 applicants around the world to be 5 companies that will be eventually down selected to one company to establish operations in Luxembourg. So we think we have a good shot at that. But in the meantime, we've been working with the other 4 companies for other collaborations as well. So we're open to all kinds of collaborations. You see, we'll need power. We'll need somebody we don't want to be the power provider as well. We want somebody to help us provide the power, provide the mobility units, and yeah, that's where we're going. Thank you very much. Appreciate it.
Great. Thank you very much, Sam. Next up, I believe we have Alex McClung on the phone from Traversal Robotics. Alex, can you hear us?
Hi. Can you
Excellent.
hear?
Yes,
Yeah.
Go ahead, Alex.
I started Traversal Robotics, an Industry 4.0 consultancy firm with the focus of enabling machines to perceive the world visually. We asked the question, how might we make industrial operations more adaptive by enabling machines to interpret and draw inferences from visual information? We train machines to interpret the world through video, with the ultimate goal of applying these learning techniques to improve operational visibility, productivity, and adaptability in industrial contexts. We pair industrial equipment with robotic hardware, sensors, and perception algorithms, and it's our belief that the seamless integration of these items is greater than the sum of the parts. Our consulting specialty is the development of tailored perception algorithms, enabling machines to draw inferences from imagery and video, extracting wisdom from operational data in industrial businesses. Perception forms a bridge between the physical world and digital representations of the world. Our perception engine models dynamic complexity of industrial processes by condensing data into meaningful representations. This involves a chain of sensing, perception, cognition, and actuation. In summary, we draw inferences from disparate sources of data across industrial operations and potentially also space, but especially with visual data. And we distill wisdom from this data to enable data-driven robot behaviors. Thank you.
Putting her on the spot, I'd like to introduce the Chief Technology Officer from the Australian Space Agency, Ord Vignel. Ord, if you're ready, would you like to say a few words while we're waiting for questions?
I'll be happy to, Liz. Thank you. I just really wanted to say how excited I was. I think that was the word of the day today. Lots of excitement. It is science fiction becoming true when we see all these beautiful graphics. It was really nice to hear all these companies pitching. I think that's one of my favorite part of this webinar, seeing the Australian capabilities that we have along all these areas of priorities that we have highlighted in our civil space strategy. So it's just the beginning of a lot of success for Australia in robotics and automation. So thank you for the team and everyone who has participated into developing this roadmap, and everyone is going to help to implement it. So excited to be here, excited for the future, and can't wait to do more of this kind of events and more project unfolding. Thank you, Liz.
Thanks very much, Ord. It is very exciting. I'd like to thank everybody who presented today, and I'd also like to thank everybody who asked questions and continued the conversation. I think it was really important. So the Australian Institute of Machine Learning were to present today, but we've had some technical difficulties getting that to happen. So we're going to record that separately and add it to the recording that gets uploaded. So just for your awareness, there is one you've missed, but I do encourage you to go onto YouTube and watch that and the rest of this webinar at your personal convenience. So I'd like to conclude the session for today. I'd like to thank everyone for coming, all of the audience and the presenters. We look forward to working with all of you to grow the Australian Space Agency. A recording of the presentation will be available on YouTube and our social media pages. Thank you, everyone, and have a good afternoon.